Okay, Assalamualaikum warahmatullahi wabarakatuh and good day. So my name is Shazwa Azli bin Nordin. My matrix number is 183861. So my FYP title will be Experimental Investigation and Mathematical Modeling of Pluronic F127 Dissolution, and my supervisor will be Dr. Faizah binti Muhammad Yasin. Okay, now I will proceed with the keyword for my FYP titles. So I will start with the first one, which is Pluronic. Pluronic is the non-ionic tri-block copolymer composed of a central hydrophobic change of polyoxypropylene flanked by two hydrophilic change of polyoxyethylene according to Erwin Smolka 1973. The second one is dissolution. Dissolution is to dissolve, is to cause a solute to pass into solution. Dissolving, also called as dissolution. The third one is micelle. A micelle or micella is an aggregate of surfactant molecules dispersed in a liquid colloid. The last one is a mathematical model. A mathematical model is a description of a system using mathematical concepts and language. The process of developing a mathematical model is termed mathematical modeling. Okay, now I will continue with the introduction. So, just like I said before, the Pluronic are the non-ionic tri-blocks copolymer composed of a central hydrophobic change of polyoxyethylene flanked by two hydrophilic change of polyoxyethylene. And as you can see in the figure with figure 1, the red one is represented the hydrophilic change with the polyoxyethylene, whereby the black one represented the hydrophobic center, which is the polyoxypropylene. And then Pluronic, also known as by their other name such as synperonics, Pluronics, and Califor. And there are a few types of Pluronic based on their molecular weight. In this study, the Pluronic used is Pluronic F127, whereby this block copolymer have a nominal molecular weight of 12,600. F127 is chosen among other Pluronic due to they are biocompatible compared to the other, which made them very popular as a drug carrier. Pluronic could self-aggregate themselves when above the critical methylation concentration into a micelle. The general methylation behavior of polyoxyethylene and polyoxypropylene block copolymers have been extensively studied. We will now focus on the methylation of F127, particularly as it relates to the pharmaceutical applications. In comparison to its low molecular weight non-ionic surfactant, the aggregation behavior of the F127 surfactant is very complex. Okay, now I will proceed with the literature review. So, according to Johann Jin 2011, Pluronic F127 is known as one of the ambiphilic block copolymer ABC, whereby this block polymer possess both of hydrophilic and hydrophobic functional group, resulting it show a good affinity for both water and oil. And according to ML Adam EL et al. 2003, the utility of ambiphilic block copolymer for the delivery of therapeutic agents result from their unique chemical composition, which characterized by hydrophilic blocks that is chemically tethered to the hydrophobic blocks. And next, according to Q. Gao et al. 2011, due to the ambiphilic behavior of Pluronic, they can aggregate to form self-assembled micelle structure above the critical methylation concentration (CMC) when placed into an aqueous solvent. They also can self-assemble. The self-assembled structure of micelle of Pluronic can be applied in drug delivery system and in gene delivery, and so on. As we can see at the in the figure 3, this is the structure of my cell, whereby the outer part is made of from hydrophilic part, whereby the center is made of from the hydrophobic part. Okay, in the figure 4, we can see that how the Pluronic F127 where they are self-assembled to become a micelle structure. Okay, next, according to Timor et al. 2000, the dissolution of drug into cells is controlled by the dissolution of F127 micelle. And according to R. Basak and R. Bondopay 2013, the factor that found affecting the dissolution rate are temperature, F127 concentration, and the stirring effect. And in addition, according to Timor et al. 2000, the addition of salt additive as one of the factor affecting the dissolution rate of F127 showed no significant effects. Okay, now we proceed to the problem statement. So the first one, Pluronic F127 is widely used as drug carrier for its ambiphilic characteristic, and also they are known for biocompatible compared to the other type of Pluronic. The drug will be encapsulated into micelle form, and the micelle could be in any size. However, the size distribution of micelle of Pluronic F127 could affect the efficiency for carrying the drugs. To ensure that the drug will be successfully carried over, the parameters that affect the methylation size need to be identified. Next, after the drug is successfully carried over, the drug needs to be dissolved for it to heal the targeted areas. It is found that dissolution of drug is controlled by the dissolution of Pluronic F127. It will be easier if we could predict on the dissolution rate based on the existing parameters such as temperature and etc. Therefore, in this study, we are going to identify the factor that affect the methylation size and the dissolution rate of Pluronic as an efficient drug carrier, and also developing its mathematical modeling. Okay, now we move to the research objective. The main objective for this research is to dissolve the Pluronic F127 and obtain the mathematical modeling on the dissolution rate of Pluronic. The sub-objective is to investigate the parameter that affect the dissolution rate. The second one, to control the size of Pluronic F127 micelles, and the final one is to develop a mathematical model to predict on the dissolution rate based on the existing parameter. Then we will continue to the significance of study. So the first one is to study the factor that affect the dissolution rate of F127. The second one is to control the size of the micelle for the Pluronic F127, and the last one is to develop the mathematical model on the dissolution rate of Pluronic F127. Here is the methodology for this study. The first one is setting the control parameter for the experiment. The second one, dissolve the Pluronic F127 in the stirred condition. The third one, obtain the data from the experiment. The fourth one is to develop the mathematical model for the dissolution rate. The last one is the result, discussion, and also conclusion. Okay, from figure 5, this is the apparatus setup for the dissolution experiment. Here is the manipulating parameters that is going to be taken account when carrying out the experiment. The first one is temperature, pH, stirring speed, and also protein concentration. Okay, now we proceed with the material and also apparatus that needed for carrying the experiment. The first one is Pluronic F127. The second one is the ionized water, thermometer, heating plate, magnetic stirrer, sodium hydroxide, hydrochloric acid, and also pH meter. Okay, now we move to the characterization. needed for the experiment. The first one is dynamic light scattering, cryo-SEM, and last one is electrophoretic light scattering. Here is the expected outcome for the study. The first one is a factor that affecting the dissolution rate of F127 is identified, and also a mathematical model on the dissolution rate of F127 also have been developed. So here is the Gantt chart for this semester. There will be title selection, literature review, supervisor meeting, thesis writing, proposal presentation, video presentation, and last one is lab experiment. So here is the reference has been used for preparing, in order to prepare for this research. So this is also the reference, the addition reference that I use for this research. I think that's all from me. Thank you for your attention.